Welcome to this Maths Heroes video. My name's Christine. I wanted to continue on with that base 60 that we started last week. So last week we had base 60 was 30 minutes and that became base 10 became 5/10 of an hour, half an hour. 15 minutes was a quarter of an hour, so 0.25, 25 hundredths of an hour. 20 minutes is 1/3 of an hour, which is 0.33 recurring, and so 40 minutes is 2/3 of an hour, or 0.66 recurring. Let me just get a decimal point in there. So I started to think about it and I thought I need to actually explain it a little bit. Maybe sometimes you go past something so that when you come back to it you understand it a bit better. What I've got here is base 60. So over here on the left hand side I've got base 60, and you can see I've got headings in the green with 1, 60 and 3,600, because that's what happens when I get to 59 seconds. So I could even put up here, we would call that seconds. We would call 60 seconds 1 minute, and we would call 60 minutes 1 hour. So sometimes with formulas and stuff, the 3,600 number comes up, and that's where it comes from. So 1 is 60 to the power of 0, 60 to the power of 1 is 60, and 60 squared, 60 multiplied by 60 is 3,600. So when I get to 59 in this column, normally we would only have one digit, so we could have 0 to 9. But actually when base 60, I can have everything up to 59. And then if I get one more second, I will have 1 minute and 0 seconds. And often it is written with double dots like that. So maybe I'll put them in here as well. When I get to 59 minutes and I do one more minute, then I would get to 1 hour, 0 minutes and 0 hours. And there's 2 spots there because I can actually have 2 digits in that same thing. Here I've got, if I do one more second after 59 minutes and 59 seconds, I will also get, so that was adding on 1 minute in black. If I add on 1 second in blue, this one will kick over to 60, which means I add 1 in the next column. So that becomes also 60, and that will kick me over into 1 hour. So it depends on whether I'm adding a minute or whether I'm adding a second. And I actually had looked up some different things so that you could see what this looks like. So here is the timer that's on my phone. So this is the timer that's on my phone. It does hours, minutes and seconds. You can see the 2 like a snake bite there to represent base 60. And I actually used the stopwatch to record 1 minute. So I was madly trying to stop it. You know, I stopped it at 59:57 and let it go again. And then look at what happened. I went to 57, I went to 84, I went to 98, and then I went to 1 minute. Because if you look at where we measure those sorts of times, so for example here, where I've got the men's and women's marathon times, you can see that there's that snake bite, that base 60, so it's 1 hour, 59 minutes and 30 seconds. So that's for the marathon. But when you're doing something that requires something even finer, a unit even smaller than a second, you can see here that I'm no longer working with the double points, I'm working with a decimal point. So after seconds, things become decimal. So I work to hundredths of a second. And that's why you see here, this 57, 84, 98, and then I went 99, 100, or yeah, and then it kicked over, but that kicked over that a 1 there kicks over because it's now base 60, and that became 1 minute and 5/100ths of a second. So that's when you need to do that sort of accuracy, because I want to compare it to base 10, because our students spend a lot of time thinking about adding 9, adding 9, adding 9. We need to teach them both ways of looking at it. Yes, it's adding 9, but it's also a multiply by 10. So if I have a 1 here and I multiply by 10, then I get a 10 here. And again, if I multiply by 10, I will get 100. Whoops. So, and likewise, going back the other way, that's a divide by 10. And that's a divide by 10. And that's a divide by 10. And that's a divide by 10. So I usually use a 10 frame to show this. So 1 divided by 10, 1 shared into 10 pieces, is 1/10, or we can write it as a decimal like that. When I've got 1/10 shared into 10 equal pieces, I get 1/100th, and that is 1/100th. So if I look at it, I've got 100, 10, 1, 1/10, 1/100th. Oopsies. Rightio. So here you can see, right, this one is 10 squared. This one is 10 to the 1. This one is, oops, here, 10 to the power of 0. And if I look at the pattern, 2, 1, 0, the next one has to actually be 10 to the power of -1, which is 1/10. So 10 to the power of -1 is 1/10, because each time here I'm dividing by 10. And so again, when I look at this one, this must be 10 to the -2, which is 1/10 squared. So if you like, I could put a little 1 there to match the one that's above the -1. So it becomes a positive when it's on the denominator of the fraction. So that's 1/10. This is 1/100th. 10 squared. Oops. I'm trying to write it small. Yeah. And sometimes it's good to see it in a different base so that you can actually appreciate how it works. Because the pattern is not about adding. The pattern is, if I start with a 2 and I multiply by 10, I get 20. And if I multiply 20 by 10, I get 200. And each time that is a multiply by 10, because the pattern is not adding 18 to get to 20 and adding 180 to get to 200. That's not the pattern, because then I would need to know where the digit is in its place value to be able to work out how to get to the next column. So the pattern is actually in the multiplication. The pattern is so if I've got 2 and I go to 20 and I go to 200, it's always a multiply or a divide by 10. So that's a multiply by 10, that's a multiply by 10. And this way is a divide by 10. Because if I was to write it like this, this would be plus 18, this would be plus 880, the next one would be plus 1,800. This would have come from adding 1 8/10. So if I even went further back. So the pattern is not in the addition, the pattern is in the multiplication. Right, so 2 divided by 10 is 2/10. And I've just seen that you can't actually see those little bits of hundredths that I was writing. So I'll just scooch over here and show you. So 10 to the power of -1 is 1/10 to the power of 1, which is 1/10. 10 to the minus 2 is 1 over 10 squared, which is 1 over 100, so a 1/100th. Sorry about that. And then, why is this relevant? Because actually we have lots of bases. So I'll just put in here. So this is the home of the decimal point between the whole numbers and the parts of a whole number. So that's what a decimal point does. It doesn't hop the dot, it doesn't shift anywhere. The numbers slide in place value. I have seen a really nice one where, to explain base 2 to young children, they talked about an alien. So we have 10 fingers, but there was an alien that had 2 fingers. And how would that alien count? And I thought that was a beautiful example of being able to access it for children. So when I have base 2, again, I've got 1 because I always need to be able to count 1. But this time, it's about multiplying by 2, and again by 2, and again by 2. Right, so this time I get 1, 2, 4, 8, 16, and so on. Right? And actually, what would I multiply by 2 to get 1? What would I multiply by 2 to get 1? Well, that would be a half. Right? So you can see the division is also happening there as well. Divide by 2, divide by 2, divide by 2. And I actually started looking at sporting again, because this is how this happens. And you know, here I've got 2 to the power of 0, 2 to the power of 1, 2 squared, 2 cubed, and 2 to the 4, 2 to the 5, and so on and so on. Usually it's in terms of computers and binary numbers and that. This one is 2 to the power of minus 1 equals 1 over 2 to the 1, which is a half. So in the binary system, I can only have 1s and 0s. So if I put a 1 here and then I add another 1, so if I add 1, then this will go to a 0 and I will get that. So that is the binary version of 2. And I'm going to put that, let me put it here. Let me put it, I'll just go like this. So that's 2. Then if I add 1 more, I get 1, 1. I can do that. That's what we would call base 10. We would call that 3. If I add 1 more to that, then this becomes a 0 because I cannot have anything other than a 0 or 1 in a column. And then I get 2. And 2, except I can't do that because that's a no-no. I can only have a 0 or a 1. So then I kick over and I say, no there, but I've got 1 here. And that would give me 4. And you can see where the 4 comes from because I've got a 1 in the 4 column. So for example, if I had, let's just make a number up. If I had a 1 here, let's put a 0 here, a 1 here, a 0 here, a 1 and a 1, you could see that that's 1, 1. I'll write that underneath. That would be 1, 1. I'd have 1, 2. I'd have 0, 4s, and I would have 1, 8. So that would give me 8, 10, 11. So this is binary 411. And what was really cool was how you could see that. If I scooch on down, look at this. Look at how sporting draws are made and how they are named, right? So it might be a little bit too hard to see, but this here is the round of 16. This is the round of 32. These are quarterfinals, semi-finals, and then the final, right? So if I was thinking about it, so there's my semi-final, quarterfinal, round of 16 and round of 32. Can you see the base base 2-ness of this, right? Because there's going to be one person or two people in the final, but one winner. There's going to be two teams. Well, let's talk about teams then. 1, 2, 4, 16, 32. So depending on how you want to count it. So there's, 32 matches, 16, so 64 teams or whatever it is. 16, is it 2, 4, 6, 8, 10, 12, 14, 16. 16 teams on this side, 16 on the other side. So that's a total of 32. It's a bit harder to see. It's actually easier to see in the Wimbledon one. So you can actually see that there's 32 teams at that level, and then each time half of them are getting knocked out. Then I go down to 16. Half of them get knocked out, then I'm down to 8. Half of them get knocked out, I'm down to 4. Half of them get knocked out, I'm down to 2. And then in the final, I get 1 left over. In the Wimbledon draw, you can see it as well. I've got my semi-finals, I've got my quarterfinals, what they call the 4th round. So so then I would have, so depending how they, semi-final, right? So here at this round, first round, I've actually got, if you can see this, it goes even further here. There's actually 128 players split over two sides, 128 players. So then this one will be 64, 32, 16, 8, 4, 2, 1, like that. And I thought, isn't that a beautiful example of how base 2 actually works? So I hope you find that interesting. All of our students are maths heroes. I think I just wanted to share how important it is to understand bases, because our students need to understand base 10 if they work in our number system. And sometimes by looking at different number systems, so base 60 is very much Egyptian, base 10, computers, on, off switches, those sorts of things. Sometimes looking at different bases helps us understand base 10 a little bit better. Thanks for watching. Everyone's a maths hero. Till the next time, bye for now.